Hello and welcome to this first tutorial for eIntegrate. We're today going to go through the basic configuration of eIntegrate in the scenario of an inbound interface component. We're going to talk through the configuration steps to get your interface up and running, and walk through a few of the configuration features just to explain what they are and how you can use them. So we're just going to start off by getting into our eBusiness Suite instance, and you can see here that we're on the eIntegrate setup screen, which lists out each of the components that we've got installed in this instance. Now, this is a development instance, so we've got a number of sort of test setup interfaces here, but I'm going to walk you through the setup of a new interface. To get to this particular screen, if I just click back to eBusiness Suite Home, you'll have a responsibility access with access to the setup or the workbench menu. How this is actually set up and your access routes in will widely depend on how it's being installed to your instance. But for this one, we're just going to jump into the setup menu. So the first thing that we're going to want to do is to add a new interface. So we're just going to click that right there. And I'll walk you through some of the setup options on this screen. The interface ID is a short name for your interface component. So what we're actually just going to put in here is I'm just going to put my initials in and the time. Just so that we can get a unique name. There's quite a few installed for this instance. I'm going to tab out of there. This one can be anything you want it to, and it should be quite meaningful to your interface component. It may be a Camly ID, it may be the name, a short name for the interface. And then we're just going to put a more user-friendly name for the interface into the interface name field. I'm just going to again put the time just to make sure that we've got a unique name. And you'll notice that when I tabbed out the interface ID field, that automatically populated some additional fields down here, which I'll talk about shortly. The application name really can be any eBusiness Suite module name. We're going to choose order management here. Now, this is important because it will actually use the application that you select to initialize the session context. So when we look down here at multiple org processing, we've got that set to no. So what will happen is when the interface launched, eIntegrate will establish single org context against order management. The data retention period field here is set to 72 hours. The data retention period defines how long the data should remain in your interface staging tables, which we'll talk about more shortly. Once we capture data in our staging tables and we process it, this setting tells us how long we should keep that data for before it's purged. 72 hours means that once the job's completed, it will schedule a job 72 hours from now to purge that data out. So we're actually going to delete it in this instance, because what that will do by leaving nothing in this field will mean the data will never get purged, and that's what we want for this particular example. Enabled, yes, we'll leave that as the default. The loader method that we're going to choose here should be SQL loader. It does support PL SQL procedures for loading data in XML, but we're going to work with SQL loader today and demonstrate the loading of data via SQL loader control files on the Unix box. The loader executable can be left blank. You can populate it if you want to actually specify the name of your loader file. I recommend that you leave any fields that aren't marked with a star during setup. If you leave them blank, they will automatically get populated with default values based on your interface ID to keep it nice and uniform in terms of the naming conventions. So we're going to leave that on blank. The package definition, this is what we refer to as the component package. The component package contains all of the code needed to process the data through your interface, and it's broken down into 4 very simple sections. We have a capture procedure, which will identify the data that you want to process. We have a validate and transform procedure, which is where you need to implement your interface validation and enrichment. So if we need to resolve additional data fields, bring additional data in, ready to populate an open interface or an API, then we do it in this procedure. The import procedure is the procedure you use to actually code your API or open interface code when you actually import the data into Oracle. And the post processor is just an additional procedure that doesn't have to be used, but basically what it means is that following the execution of the interface, the entire interface, this procedure will execute post processor, and you can do things like launch other programs, launch other interfaces, whatever you want to in there, really. The important thing about post processor to understand is that you are guaranteed to have received a commit following all of these procedures above. So your data will be committed and in Oracle by the time that this runs. It may be that you want to run auto invoice or some other process following an import of invoices, for example. These will be dependent on the type of interface that you're putting together. Earlier on up here, what we didn't see is that there's an interface type selection here of inbound or outbound. We've left it to the default of inbound because that's what we're doing today. But obviously, if you change that to outbound, some of the names of these fields would change. And it, for example, wouldn't be capture. It would be extract. Validate and transform would stay the same. And then import would have changed to output to follow the trend of an outbound interface. The workflow notification role is what it says, a workflow role, and what will happen is that in the event of your interface errors or goes into warning or even completes successfully, this particular interface will notify whatever role we put in here. So we're actually just going to choose our username, now. Obviously user roles in Oracle are coupled with user accounts and responsibilities, so you'll be able to see whatever, you'll be able to send notifications to whichever role you choose there. You can also obviously create ad hoc roles in workflow and specify those here as well. So on this interface, we've said that we want to be notified by error. So in the event the interface goes into error, this workflow role will be notified. We're not interested in receiving a notification on warning. In the event that the interface finishes in a warning, it will process as normal and do the import into Oracle. It will just end the process in a warning with the relevant warning messages. But we're not interested in seeing that, so we're just going to set those to no for that and success. Obviously, if you want to be notified every time interface runs, you can set success to yes, warning to yes, error to yes. The notification timeout defines how long to wait for an action from a respondent. So if we receive a workflow notification to say our interface has gone into error, then we can set this period to whatever we want to say. If they don't respond within 72 hours, then resend the workflow notification, which is standard workflow functionality for managing notifications. The security function restricts access to the interface. So if we assign a security function now to this interface, which you have to do, then the person accessing the interface will need to have the security function assigned to their menu somewhere in their responsibility setup. So if we there's a default one here that we're going to use, which is just an XXEI one. Just wait for that lookup to load. The functions need to be created manually prior to configuring the interface, so you can come back later and change the configuration. We've already got the security function that I'm about to assign, so that wouldn't be a problem. Okay, so we're just going to select that there. Okay, so the exception method that we're going to choose here is going to be restartable. What this means is that in the event the interface goes into error, it will send a workflow notification requesting if the user wants to terminate or restart the interface process. Now, when an interface process restarts, what it will do is it will take a copy of the interface records that haven't been processed. It will start a new interface session and attempt to reprocess them again. If it terminates, then it will just stop the job in its tracks. So anything that's unprocessed will be set to terminated, and it won't go through. We're going to set it to restartable so that we get notified. And we've also said that we want to include detail and message and summary messages upon conclusion of the interface. Now this will affect what gets output to the concurrent manager log file at the end of the process. Now you can also access these errors elsewhere in the eIntegrate screens. This just purely controls what gets displayed on the final output report. So if you've got a lot of detailed messages to get output, you may only want to show the summary messages on the output report and then review the detailed messages in the application later. In this instance, we're just going to click both so that we can demonstrate that functionality. The concurrent program is the concurrent program for your interface that actually starts your process. We're going to leave that blank and we're going to let that name default, and we'll come back here later to see how these are populated. So that's the basic configuration. All of the more information about each of these settings can be found in the eIntegrate developer guide. I recommend that you go and read that through and understand the different configuration options here. The important thing to understand is that these settings are going to generate a number of objects when we generate our interface, which we will come to later on in this tutorial. So we're just going to click Next for now and move on to the next screen. Now this is where we set up on the train flow here. You can see we're onto our staging table definition. This is where we specify the data structure that's going to receive our data in from the file that we're importing. So rather than have to create a table manually, we're going to be able to do that in this screen. We're going to click Add New Table. Now you'll see that it automatically defaults, and what we've got here is the custom application prefix of the environment you're working with. This is a configurable profile option that defines what can go in here, and it's used by the software to automatically generate all of the objects. We've then got that followed by the interface ID that we specified in the interface definition screen, and finally a standard suffix of _stage to indicate that this is a staging table. Now the description of your staging table can be important if you're intending on using Web ADI to interact with the data in your staging table. The description that you enter in here next to your table is the name of the actual Web ADI integrator, the actual ADI template that gets generated. So we're just going to put in here a sample name. And this obviously can be more meaningful for the interface that you're developing. It could be obviously related to AR or order management or any of the Oracle modules, and you might want to put something more specific in there as to what it is that the data entity is that you're working with. The Web ADI view name, obviously you can see no stars here, so we can leave these blank. I'm going to leave this one blank here to let it automatically generate so it's in line with the name of our staging table and our other objects. Now, I'd recommend that you do that unless you really need to name all of the objects with different things. It just gives you some consistency between your object names. Okay, so if we scroll down here, then what we can see is the configuration of our staging table. So you'll note that there's a lot of standard fields that go in here. A lot of them you will recognize, so all of these ones here, the later fields are the Oracle Who columns that will record information about what's going on with the data in that table, the concurrent request ID, who created it, when it was last updated, etc. You should be familiar with these fields, and they will be there as standard. You can't remove them or edit these particular fields. These have to be here, and the ones above that here are fields that are specific to eIntegrate. So the record ID will define a unique record in your staging table. The execution key identifies the session ID, that the record that was processed against. It's a unique key for an interface job. The status of your row will indicate where that particular data row is in the integration process. A file ID will identify the file that the data was actually loaded from, and that relates to other tables in eIntegrate to obtain the file name and load location. The approval status refers to If approvals have been set up against your particular staging table, it means that nobody can modify the data without an approval being made against that change, to give you some security around your interface process. That can vary in its status to indicate whether it's a currently active record, a pending approval, or an approved change. And that will be highlighted to you in later tutorials. Okay, so we've got our basic staging table there, and we know that it's going to be called this up here. We know that we've got these standard fields in here, but we want to add some new columns. Now, we can add some new columns here by clicking on our Add New Column button. I'll show you that later on. But what we can do for speed is that if we know we already have an interface file that's got header columns in it, perhaps, or you want to just map out in a file the columns that are going to be in your staging table, then we can use a comma-separated value file to quickly populate this screen. I'm just going to demonstrate that to you now. So on my desktop here, I have got a sample file that's got 4 column headings in it: column 1, column 2, column 3, and column 4, separated by commas with no terminator on the end. So we're going to use this sample file, and this should become clear as I go through this process now, as to what happens with that file. If I click Browse on this screen, and I just try and find that sample file, which is there, and I click Open, and I'm told it's a comma delimited file. We can also have a tab in there or other, and we can specify what the delimiter is. If we just click Go on there right now, then what we should see is that those rows will populate in between our standard columns. So we can now see that we've got column 1, 2, 3, and column 4, which was in our file. It's defaulted their types as varchar 255s. And we can edit those fields here by clicking on Update. I'm also just going to click in an additional column 5 just to demonstrate the Add New Column field. So we click Add New Column, and it will automatically default the next sequence in. And we're just going to put in here column 5. We're going to specify that as a varchar 230. It's not a mandatory field, so we can leave that as to no. We're not going to give it a default value. The purge key against a field identifies whether or not that particular field can be used as purge criteria. So, for example, if we had a status field coming in from an interface file, maybe we'd want to delete all records that had been in a certain status. So we can use that to say, yes, I want to be able to use this field as purge criteria, and that we'll examine that later on in other tutorials. But the purge process would use that particular field. In this instance, we're saying no, column 5 is not going to be used as purge criteria, so it won't be available to us in the purge program. So we'll leave that be. The fields here about display and read-only are used to indicate whether or not this field in our staging table can be edited or viewed in both the OEF screens that are part of the product, which we refer to as the workbench, or in WebADI. So it defines whether or not the field will download in WebADI, display it set to yes, read-only set to yes. If we wanted to be able to edit them in WebADI or in the workbench, then we can just set those two to no for read-only, and that they will be available to us to modify later on in the process after data has been loaded. The defaults are that they will be visible, but they cannot be edited. But all of this can be changed later on, so if you want to get through basic configuration and modify this setup, then that can be done. If we click Save here now, it will jump us back onto our staging table screen, and we'll see that our column 5 has been edited in there. If we wanted to change the format of one of these fields, then we can click on the Update icon next to that row, and perhaps we wanted to change that to maybe a varchar 250. We wanted to save that. You'll also notice that the workbench options and ADI options are available here for us to view and to modify. So we can do that here rather than have to go into the individual update screens. And we can also affect these settings for our standard columns as well, which obviously you can't change anything else, but we can modify those. Okay, so we've got our staging table put together there, and that we're going to use for this demo. So we're going to click through onto the next screen, which takes onto our parameter definition. The parameter setup here is used to add in concurrent program parameters. Now, these are standard concurrent program parameters that you can see here, and these always need to be left in place. We shouldn't really modify these unless there's an absolute requirement to, but they are used internally by the software to launch the process. Two of them you won't be able to see. You'll only see this one usage ID, which determines under what usage policy the interface is executed under, which we will talk about in the next screen. So we're going to leave our parameters set for now. If we add any in here, then these will be added onto our concurrent program that gets generated at the end of this tutorial. But let's just leave that as it is for now, as the defaults. Click through to next. Okay, so this is the usages screen. Interface usages are basically if you've got an interface that you want to be able to be used by multiple sources. It might be that you've got 3 different systems interfacing data through the same interface process, and you've got 3 different file formats. We can define a usage in this screen, which allows us to give some granularity over the settings that we made in the interface definition screen. This screen basically copies these settings down from the interface definition onto a usage. So if we wanted to customize that configuration dependent on where the data is coming from, then we can achieve that. Now we're just going to select some defaults in here, and for the source and the terms and the data transport profile, so these fields here, 1, 2, and 3, these fields selection values should have been predetermined by your data architect or your integration architect prior to you configuring this interface. So that should have all be available to you already. We're just going to use some default ones that have been set up here. It doesn't really affect the execution of the interface. It's more for tracking and reporting purposes. But we're just going to pop those in there. As you'll see then now, you'll start to see some familiar settings from the first screen on the interface definition. So we've got the security function we selected, the exception method, all of the settings that we selected previously. Now we're going to leave those as they are. That all they've done is defaulted down, but if we wanted to modify them at this point, we can customize them at this level. And if you want to change these settings later on, you have to come in and change them at the usage level rather than the interface definition level for them to be effective. Okay, so we're just going to submit that process now. And you'll see here that our interface is sitting at the top of our table here. It's an inbound interface and we are ready to generate. Now, auto generation will actually build the interface components for us so that we don't have to do that manually. And if we click into generate interface, we'll see a screen with a number of options. There's a number of jobs here, 6 in total. The first one will generate the concurrent program for our interface. The second one will generate the staging tables that we need, the database tables that we need. The third one will generate APIs that are used to interact with the data, what we refer to as the data package. The data package is used by the OEF front end and by Web ADI to interact with the data in the staging table, which we'll cover at a later date. The generate interface package template is our component package. It's where the interface code lives, and that's what we're going to be coding in a later development tutorial to show you how to build the interface logic up and how to work with your records. The generate file import and export setup will generate everything that we need on the Unix server to place our files and load them into our staging table, and the Web ADI generation process will generate our Web ADI integrator, which will enable us to interact with data in our staging table. So we've got all of our jobs selected here, and we're going to click on generate, and the job will start to process. Just going to click refresh request status here. We can keep doing this. We can obviously see that all of our jobs have been scheduled. The programs are set up to be incompatible with one another, so you won't get them all running at the same time. We have to wait for certain things to have been done before the next one can start. So we can see here now that we've just successfully generated our concurrent program. I'm just going to wait for the other jobs to finish now. We've got our interface table process which is running. It can be worth just inspecting the logs on these jobs just to make sure you've got no error messages or anything that looks like it may have gone wrong. Generally, if something goes wrong, then you will get a big red cross next to the job. You can inspect the log file here to have a look at what those particular errors were. So we're just going to wait for the concurrent log file here just to load up, which is being a tad slow. There it is. So we can see here that we've got a standard message output. There's nothing in here that we need to worry about. If you don't see any errors, then you can assume that the process has gone through okay, and I'll show you how to verify each of the objects when we complete this process. So I'm just going to click refresh status there. We can see now that we've got 4 jobs completed. We've got our current program, we've got our staging tables, we've got our interface table APIs, and we've got our component package. We're just waiting for the Unix box to complete and the Web ADI template, which is now also completed. And very shortly we should have our and there we go, we've got ticks across the board. That means our final job is running and generated our Unix box components. So I'm just going to go into Toad and verify this now. So if we just take our component ID from the top here, I'm going to open Toad up. I'm just going to do a quick select star from all objects. Just a very quick way for us to see all of the database objects that we've generated. Now, we'll see in here a lot of objects, but we can verify that, first of all of our objects are valid. We can see that we've got a data package here, which I referred to on the job screen here. So this generate interface table APIs has generated our data package for us. We can then see we've got another interface package here, which is made up of our custom prefix, interface, inbound, interface ID, PKG, and that was generated by the generate interface package template job here. We can also see that we've got a number of directories suffixed with SPC and A. Now the IDs here refer to the staging table ID, the interface ID, and the usage ID, and then have a number of lower level directories, SPC and A, for staging, for processing, for archive, and for complete files. And we'll talk a bit more about those later on, and we'll also have a look on the Unix box shortly as to where they are. So we've got those 4 directories generated in the database, which will have the actual path references on. And if I just do a quick selection from all directories, then you'll be able to get the paths of your interface location. This is the location of our staging folder where our file should be placed. So when we interface our data file, this is where the interface file will be dropped into our stage location, which is where it will then get loaded from. eIntegrate will automatically load the file when it's received into your table based on your SQL loader control file, which we'll go over in a second. But just as a quick reference, you can always look the directories up to find the location of your staging directory. And if we actually just remove the S from here, we do a like, then we'll be able to see all of the locations here. Staging, process, complete, and archive. A file will come into stage. It will be moved by the file daemons into in process, where it will be loaded into your table. If that completes successfully, the file will be put into the complete directory. If it fails, then it will go into the archive along with the bad file and the original file, so that you can get that data back if you need to move those files around to reprocess them. Okay, so that's the directories. We'll also see some other things in here, which I won't go over in too much detail right now. We've got the staging table itself, and we've also got an archive table. So this is our staging table here. This one here above it is the archive table, so eIntegrate will automatically allow you to archive records. It will also keep a history in the archive table of changes made to your data following the reception of the interface file. That may be due to people modifying the data, following exceptions. It might be just a process thing that goes on, but that will record full audit capability for the interface. We've got a couple of sequences there that are used by the process to populate your record ID in your staging table, synonyms for the objects, and we have views that are built in here. So we have a view for the staging table, which just sits on top of your staging table. There's nothing fancy in that at all. We have an archive view, which sits on top of the archive table, and then we have a history view, which sits on top of both of those two views to give you an overall picture of all of the data. You need to be careful when using that view, because obviously it contains historical data, a little bit like HR date track, in that it will show you multiple instances of the same record if that data has been changed. But the common rule is that if you're looking at current data, then you want to be looking at your staging view or directly at your staging table. Okay, so that's all of the database objects. What we're also going to do here is just jump onto the application server. Now we know that the the directory that we created here has got a path on the server. Now you'll see this path here up until you've got your custom top that's being implemented here. Now there is also a shadow custom top which isn't physical. It points, in this particular instance, it points at the custom top. Depending on your instance, that may actually be a physical XXEI top. But if we just CD to XXEI top and we CD into the in folder for an inbound interface, and we list that directory location, we've got a number of directories here. But if we actually just look, we'll see we've got our interface ID, which is there just after the in folder. So if we just take a copy of that and we CD into that directory location and we do another list, then what you'll see here is that we have got a couple of files that were used during auto generation. You don't need to worry too much about those, but we've then got a further path here of 8167. So if we change down into each of those directories, so CD80, CD1, CD7, 67 rather, and then we do a list, then we'll see that we've got the folders that I was discussing previously. So these folders, I'm not sure if you can see them too well because of the highlighting on my putty instance here, but we've got an archive folder, a complete folder, an in-process folder, and a stage folder, which mimics what we've got here in the database, and you can get the paths for those locations from there. So that's how we verify each of the objects in our setup. Now, what I'm briefly just going to show you how to do is how to start the daemons up and place a file. So and have a look at our control file. So if I just click back to the interface list here. If I go back to my home menu, we now need to come out of setup into our workbench. So I'm going to click on workbench, and this is a suite of screens that's used to manage the interface process, and we're going to use it here just to start up the file daemons. Now, we know from where we are that our interface ID is KT1157 here. Okay, so we are just going to try and select that. So let me do it without too much fuss. Okay, and we're going to put in here the interface user ID field, KT1157. Click go. What we should get back is our interface here, so we can see some basic information: the interface name, the interface type, interface usage, and we've got some commands here to start and stop the file daemons. We've also got some information about the jobs that are running, which are all set to 0. If we click show here, then we can just see that this all shows information about the file daemons that are running for this particular interface. Now, if we had multiple usages on this, then we'd get multiple daemons. In this case, we've only got one, but what we're going to just do here is we're just going to start up the interface daemon for our interface. It's going to ask us to confirm, and we're going to say yes. And what this will do is this will start our file daemon process up to monitor our stage directory, waiting for files to be dropped into that location so that it can process them into our staging area. And once this job's complete, it will take us back. We'll see that our daemon ID row is now populated. We can see the path from XXEI top in directory KT1157 8167, and that's where this daemon is currently monitoring our stage directory. We can see that it's looking for an SQL loader control file to do the drop. Now, this means that it's now actively monitoring, and we can load files to that location. But how does it actually do that? Well, if we actually go back to our setup, then we review our interface setup following auto generation, then we'll see in here that we've got a number of fields that have been populated. The concurrent program name has been populated, and you'll note that that is the same as the interface ID. So to run our concurrent program, the interface ID can be used. That will be the name of our program, and we'll cover that in a development tutorial later on, not for the scope of this particular tutorial. But we'll also see that a loader executable has been populated, which I'm just going to grab the file name of, and then I'm going to jump back onto the Unix box. And I'm going to CD to XXEI top. I'm going to CD into the bin directory, which is where we should always keep our SQL loader control files. I'm just going to do a list on that name we've just pulled back, and you'll see here that we've got a control file. Now, if we just take a look at that control file, it should automatically have been populated with the columns that we specified in our staging table, column 1, 2, 3, and 4. So we know that our interface file can be loaded based on these 4 columns. This file should work straight away out of the box. What I'm actually going to do now is I'm going to jump to my staging location. And we're going to attempt to load a sample file. Okay, so we're in the stage direction now. I'm just going to back up out of there to construct my file so it doesn't start loading it as I'm modifying it. The daemons won't load a file unless a file's not been touched for 2 minutes. So we should be okay to create it in the stage directory, but just erring on the side of caution. So I'm just going to create a file called test.txt. I'm going to put val1 in there, val2, val3, val4, val5. Okay, I'm just going to write and quit that particular file. So I've got 5 values in my interface file. Now, if I wanted to, I could modify my my control file at this point. You can do whatever you want to your control file. You might want to load data to multiple tables. You might want to put some validation in there. The full functionality of SQL Loader is available to you. I'm just going to open that file up there and just double check. We've actually only got 4 columns here. Now I believe that it probably should have generated 5, so I'll just need to check that out. But we've put 5 values in, so I'm just going to insert mode here, and I'm just going to put column 5 in there. And if we have a look at our staging table, if we just do a quick query back on all objects. Okay. Okay, we're going to do a quick select star from. And we'll be able to have a look now here at the definition of our staging table. We can see that we've got our 5 columns, column 1, 2, 3, 4, and 5. That's what we're going to attempt to load data into. So we've specified that now in our control file. We're just going to escape right and quit out of that. Okay, and we're going to change to our staging table directory location. Let's do a list on that. We can see I've got our test.txt here. I'm just going to move that file into the stage directory. Now remember, our daemon is actively monitoring at this point, so we should be able to see that file disappear at some point. But if we want to monitor the process from Unix here, we can modify. We can look at the current log file, which you'll see is dated today, 1st of January 2015. So I'm just going to do a tail on that file just to take a look at what the log file's seeing. So it's telling us that it's got files available in the directory to process. Now what it will be doing here is it will be waiting for a couple of minutes just to make sure that the file hasn't been modified. It's not going to get further modifications made to it, which will prevent it from writing the data to the table whilst the file is being written by whatever FTP service is moving the file into that directory. So it'll just keep polling, and it knows there's a file there, so it's going to keep checking it just to make sure that after 2 minutes it's not been modified, and then it will attempt to start the load process. Now what the daemon will do here is it will actually launch a concurrent process that will which will load the data into the table from the file using the control file that you specified in your eIntegrate setup. Which we saw earlier on this loader executable here, is what it will use to load that data that we've just examined on the Unix box and modified ourselves. So we know our data is in our file, it's in our staging location, the daemon is running, which we started up from the workbench, and that data should now get loaded into our staging table, which we'll just do a quick query on just to show that we're not doing smoke and mirrors here. So we've got nothing in our staging table at this moment in time. It's still just polling there, waiting for that file to become dormant enough for it to load the data into, and we just popped up there that there was a concurrent process launched, and it's now saying that there are no files in the directory for us to process. So I'm just going to come out of that, and I'm just going to take a look at our staging table, and we'll see that our values have been loaded from our control file, using our control file into our staging table. And if we take a look, if we just take a look at where we are right now, we're in our core interface location. So if we list that out, we've got our staging directory, which should now be empty. It is. Our file has disappeared. If we have a look in our complete directory, because the interface process did seem to complete successfully into staging, we can see here that our test file has been moved and suffixed with the concurrent request ID of the process that loaded the data. Now that concurrent request ID will always be added onto there on a complete file, and if we ever want to find out if something's gone wrong, then all we have to do is go and look at that concurrent request, which will give us the SQL loader output messages for us to debug in the event that we've got a problem. So we can see now that our data has been loaded into our staging table, and it's ready to process. And processing the data from this point on, we'll discuss in a later tutorial. But for now, thank you for watching, and please take the time to have a look at our developer guide and the subsequent tutorials to get a better understanding of the actual interface process from this point. Thank you.